hub number 1 is about demonstrating a sustainable supply of rare earth elements, but mainly from primary materials. You will see we will deal with direct mines of rare earth ores or some tailings. And we will the objective of the hub is to demonstrate the full supply starting from mine and tailings to separated and purified raw materials to be used in magnet production.
Move on.
Yes, please.
Okay.
Yeah, maybe one missing element, which is an important point as well for hub number 1, is the word sustainability manner of extraction. So this is really a core activity of the hub number 1, is to demonstrate this supply from mines in the most sustainable way for Europe. Okay. So
just tell me when to move on, okay?
Okay. Here maybe just to give a very quick summary about the task. So the hub number 1 will be structured in 5 different tasks. So first one is around is around defining the supply chain for permanent magnet, and for that we will deal with rare earth concentrates coming from different rare earth sources, as I said. So here I'm mixing tasks 3.1 and 3.2. Then in the task 3.5 we will work Solvay and Técnicas Reunidas on the separation processes. So from first extraction and valorization beneficiation processes up to separations. And for that we will split the work on two main streams. First stream is the light rare earth separation, and the second one that will be led by Técnicas Reunidas. In addition to all the first steps of the beneficiation processes that will be in collaboration with the different mines or tailings in the hub number 1. And the second stream is the heavy rare earth separation that will be led by Solvay. Maybe this is explained in the next slide. Yeah. Okay. So this one is around as we will have. You can see here the contributors. So we will have different type and origin of primary raw material containing rare earths. Some coming from Leon, some coming from Pentana, some coming from Aridos. And also quantum. So the idea is to assess all these raw materials in order to be able to fine-tune the right processes for each type of raw material. Please, Simon, go
Yes.
on.
Should I just move to task 3.2?
Yes, please. Okay. So here in task 3.2, this is so quantum with Técnicas Reunidas started to work on the valorization of the raw materials from quantum, and the idea is to scale this with quantum and Pentana, and to treat to involve deposits from Quantum mine and Pensanas mine. And the objective is to treat around 20 tons of this mineral concentrate within the hub number 1.
Okay. Move to task 3.3.
Yes, please. Yeah, this is another innovation model where hub number 1 will deal with in collaboration, of course, avec Leon, because here we will deal with another type of rare earth tailings coming from iron mines owned by Leon. So this is another stream of valorizing raw materials containing rare earths. And this will be led in collaboration with between Leon and Técnicas Reunidas, going from the assessment of this type of raw materials up to the first steps to make the rare earth concentrate ready for later separation of light and heavy rare earths.
Okay, we're at task 3.4.
Okay, it is linked. It is linked to the valorization of the tailings. Here, what is mainly highlighted is the difference in concentration. If you go from typical rare earth ores like monazite, bastnäsite, etc., the concentration of rare earth elements will be much higher than in tailings. That will add big challenges in processing the tailings in order to make let's say economically viable and sustainable process, and this is the challenge of this task. Yeah, and that one. So for the task 3.5, this is what I just explained before. So after the assessment of the different raw material coming from mines and tailings in the previous tasks, and also creation or development of very dedicated process for each rare earth raw material or primary raw material, which include the first so leaching and beneficiation and concentration processes, as well as all the mechanical ones. We will end with mixture of rare earths, either carbonate or oxide or oxalate. Okay, and from this point, we can start the separation processes that will be led in collaboration between Solvay and Técnicas Reunidas. So Técnicas Reunidas for the separation of light rare earths, and Solvay heavy rare earths. So light rare earths Nd and Pr, and heavy rare earths dysprosium and terbium. And both companies will make the so there will be 2 demo. First one is from mine to NdPr oxide, tailored in order to be used for magnet market, and demo and the other demo is Dy and terbium oxides, also with properties going in adequation for the magnet production.
Okay.
I think that's
it.
That's what I can say about the hub
No,
one.
I think I saw Peter joining, if I'm not mistaken. I saw last name Fleming joining. But maybe not.
No,
Uh,
it's not. It's not Simona.
Okay.
Okay.
Zhao, there was another question from you. And basically, I will just read it to Lama. Sorry, I can't speak at this moment. I was wondering whether you are planning to use H2 disruptation method or traditional thermal treatment method to separate it directly, or other new technologies. And why I was asking is because I got to know some startups claim that they can separate magnet from rotor without any thermal H2 gas treatment. And their method sounds very cost and energy efficient.
Okay. I think this is more linked to the recycling hub, and of course, if is there any collaborator from Mag Resource, please jump in to answer the question. Here for the hub, for the short loop recycling, we will be focusing on hydrogen decrypitation method. So
that answers that question.
Yes, and yeah, if Zhao Zhong, you want to add more details about the new process you saw, that will be helpful for all of us. But for hub number 2, we will be focusing on hydrogen decrypitation.
Okay.